Welcome in our Ekascloud online course first lesson created by Peter Benko. Before we go any further in terms of cloud services, understanding the cloud as a service, we need to first get familiarize ourselves with number systems. A MAC address, what the MAC address is, IP address, classes and subnet mask. So this is the agenda for first lesson. So let's start with a binary system. So basically the computer itself using for calculation, for communication and all sorts of process zeros and one as a number, and the least unit what can be used is built from 8-bit, which is 1 byte. That 8-bit has 8 digits of 0 and 1. Now obviously this is not going to be easy to understand for any human if we want to know what's going on, and then therefore it would be useful to have it in a more human readable format, like a decimal, using decimal number systems, which is numbers from 0 to 9, and then there is also another one. It's called hexadecimal systems, which is 16. It consists of 16 numbers and letters. The hexadecimal number system is something in between. Also, the main idea is to use it for better understanding, the easier reading, although in the background the computer is always using binary system, zeros and one. If you want to convert these numbers from binary to decimal or vice versa, it is always good to keep in mind this format where 2 on power n or 10 on power n is 2 is called like a base value and n is like a place value. The n is going to be the place where the particular digit is. So if we start from right to left, then the right first number is basically 2 on 0, which is 1. Then we go next. 2 on 1 is 2, 2 on 2 is 4, 8, 16, 32, 64, 128. So this is the 8-bit representation of binary number. The same concept is behind the decimal number system, where the base value going to be 10, and then every other digit is going to go to the power the letter n. The hexadecimal number system is a little bit more complicated from that point of view, but it is still easy to understand because it consists literally as a numbers from 0 to 9, and then the numbers 10, 11, 12, 13, 14, 15 are replaced by letters A, B, C, D, E and F. So this is also used in computing pretty much for easier understanding and reading for the human, not really for for the device, for the computer. And so once we understand that conversion between binary and decimal system, then we can go further and talk about computer networking. Basically, the most simple solution to connect to computer is by connecting with a cable. But how do we connect the computers? The computer needs to have it's called NIC card, which is a network interface controller card, and well, in 20-30 years ago, the NIC card had to be installed into the computer. Basically it was a standalone unit. Nowadays the NIC card is the part of motherboard, so basically we already have a port where we can connect our cable and join to computer, connect to computer. So basically then what is important to understand is that every NIC card has a MAC address. MAC address basically stands for Media Access Control, and what is really important is that basically a very unique number. There is no other number like that what you can find on some other devices. This is a very unique number, and then basically it gives the name of the computer. Or if you like, then we can call it as with a question, who is it? Alright, and the MIC code tell you which computer is that, who. Now we can demonstrate here a quick proof. Let's say get MAC and find out what is our MAC address of our computer. There you go. The physical address is expressed in a hexadecimal code, as you can see, and there are 4, or better say 3 different devices. Each device has this unique MIC code, the MAC address, and that's basically how we can find out which computer is that in the network. Now the second thing what we want to know if we connect computers is where are they located. So for where are they located is another address which is called Internet Protocol address. There are now 2 different versions, version 4 and version 6. Right now let's just deal with the basic format of IP address, and then later on in the other lessons we may explain what's the difference between version 4 and version 6. So basically these Internet Protocol addresses says where is your computer in the network structure, where they are exactly located. Now The Internet Protocol address can be static and dynamic. The static is you cannot change, while the dynamic, the Internet Protocol address can be changed while the communication is established between two or more computers. So the IP address looks like four numbers. Basically, if we express it in binary system, then those four numbers are actually creating a 32-bit format number split in 4 octets. So here we can see 192.168.0.1, which is a human readable format, but obviously the computer is able to understand only binary system. So in binary system, if we write down the numbers, then soon we find out that actually those are 32 bit format numbers, creating a 32-bit format number. Now when the two computers are joined, then the network can understand where is located, and the host bits, basically network bits. It consists basically two parts. One is the network bit, and another one is the host bit. What is the difference between these two? Also, we'll discuss later on in other lectures. And here you can see these 4 octets can be categorized and add to the class. So the first octet, if you look at it, is 8-bit goes to the network bits, and the rest goes to host bits. For the class P, 16-bit goes to the network bits, and another 16-bit goes to host bit. And then for the class C, 24-bit going to the network bit, and 8-bit going to host bit. Now this is the easiest way to recognize whether the IP address is class A, B or C. If you look at the first octet, if it is in a range between 0 and 127, is going to be class A. In range B, 128 and 191, class B, and in range C, 192 223, class C. And accordingly then we can use subnet mask, which purpose we will explain, I believe, in the following lessons. But what we need to understand is that if we add all the possible values what we can get from 8-bit, so if we come back to this slide, and if we add 128, 64, 32, 16, 8, 4, 2 and 1, then we will get 255 as a result in decimal number. And this is the number what we will use to to add this extra information to the computer to recognize which one is the network bit and which one is the host bit part of IP address. So if is it only 8-bit for network bits, then the class E is going to have a subnet mask 255.0.0.0. If it's going to be 16-bit, then the first two numbers going to be 255.0.0 for the subnet mask. And if it's class C, then 255, 255, 255 3 times goes for network bits and 0 goes for host bit. So this is also another way to identify the classes A, B and C. We didn't mention the D and E. Those are right now not active, not valid. Only the numbers up to 239. Oh, sorry, 223. 223. So this is it for today, first lesson. I hope everyone understand what I try to say here. If not, feel free to ask, and if you don't wanna ask, then just stay still, wait till we get to the next lesson, so that may give you more understanding what's going on and why we are talking about IP address and their subnet mask. So that's for today. Thank you for your attention. Bye bye.